I wanted to start off this video by having you do some practice. On this particular slide, effectively what I want you to do is type the word which and then the program commands that you see on the screen. The output of the which command will give you the path to the executable. Then go to that location and type in ls tac long, and you can see whether that file needs root privileges in order to run. And in this slide, basically all you need to do is find those files and identify whether they're in the etc directory or whether they're in your home directory. Pretty easy, but they're important files, so knowing where they are is important for later on when you administer systems. So we've talked about processes a little. Every time a user runs a command, a program is run and one or more processes are started. Now each process is given in a unique ID called a PID, process ID, and likely a parent ID, a PPID. Now you can show the current processes by running the top command, which provides a changing dynamic list of running processes. And it's a fine command, but I recommend you install the htop program and look at running processes to see how that's shown a little bit differently, same information. Now, if you want a static list of running processes, you can use the ps command, and I especially like the pstree command, which provides a graphical representation of running processes with a parent and child processes shown, much like that tree command that provides a graphical view of a file structure compared to ls. And look at the help for pstree, and you'll see that the tacp option provides the PID for each running process in the tree. Very nice. Now the ps command is in itself very nice, excellent. For example, you can show active processes by username using the tacuf options, or use the tacx option to see the current running processes and the commands used to launch the processes. So if you want to know who executed a command that made a process run, type the tacuf. And if you want to see the commands that were used, type ps tacx and you'll see the command associated with that process. Very nice. Now each running process has a related virtual file. Remember we talked about that in the proc directory, which you can look at. So if you type in, let's say you get the PID for some process that's running, like ls proc 898, that's happened to be a process that was running at the time when I was making these slides for something called whoopsie. And find the command line file in that proc PID and cat it to see the executable file that was used to launch the process. So that all sounds great. Let's go ahead and practice with these commands just so you can see what it looks like. So let's go ahead and look at our processes. Let's start by typing the top command and you get to see a whole bunch of processes. Let it refresh dynamically. You see, hey, look, there's some processes related to Sal. When you want to exit out of it, you type Q to exit out. Now, let's go ahead and clear it and run the htop command to see the same information, but in a slightly different format. I like the way htop looks. If you don't have htop installed, type htop and install it so you can also see the differences between top and htop. Excuse me. Now, let's go ahead and run pstree tacp to see the current processes that are running with the IDs and the child processes with their process IDs. So look, there's a process called whoopsie, which you can look at. It's kind of funny named, but you can go up and look at all these different processes that were started, the subchild, the child processes and their IDs. Let's go ahead and clear that. Now let's look at the processes that you launched or that were launched by the user. So if I go here, I look and I see the bash process has a PID of 2443. The command was bash that launched it. I even have a process there for when I typed pstacuf. Now when I type pstacux and I go look, I can see that, okay, look, there's a whole bunch of processes that Sal started from using different executable commands. But go down to the bottom and look and you'll see there's my Sal bash command and even the executable that I typed to launch this particular thing of pstacux. Let's go look at something simply called uptime. What does that tell you? It tells you how long your machine's been running. So you can type uptime, it gives you some nice information. Want to see where the executable is located? It's in user bin. If you don't want to figure out how to read all that stuff when you type up time, use the TACP option. It tells you exactly how many hours and minutes, which is kind of convenient. All right, so I know what you've been thinking. You've been waiting a long time and we still haven't talked about log files and you're tired of waiting. Well, good news, let's talk about it. Log files are very important if you're trying to troubleshoot problems, especially with the daemons, which are programs that run in the background of your Linux system. Now, some important daemons include DHCPD, which is DHCP daemon. What does that do? It implements DHCP. There's also one called CUPS, which is the daemon for printer services. Then there's cron D. It's the automatic task scheduler related to cron jobs. And there are many, many more daemons. Well, those daemons usually, or particularly some of them, develop logs that you can look through to see if there's any problems. Now, most log files are stored in the var log directory, and they do vary by Linux distro. Now, Linux applications use system log daemons to do the logging for them, and some important logging daemons include journald, which we'll discuss shortly, syslogd, and there are others. Now, fortunately, you can view most log files like they were just a regular old text file using cat, more, less, and tail commands, some of which we've already used. However, some log files are stored as data binaries, and you will need to use the last command to read them. And if you want to identify whether your log files are ASCII or data, you'll use something called the file command. And, well, let's just go ahead and use those commands now. So let's go ahead and look at those commands. First, let's look at the last 10 entries in the auth log, which you can probably guess holds logs for authorization attempts. Now we're going to use the tail command, and you can feel free to use the man pages for tail. But first we're going to cd into var log, and then we're going to ls just to see what's there. Now, are there any old auth entries? Well, yes, there's auth log, then there's auth log 1, and then you see auth log 2, 3, and 4 GZ. So that's what happens when you get old logs. They'll go ahead and get zipped, but they'll be stored for easier access later. Now go ahead and tail auth log, and you'll see the last 10 entries. Okay, great. Now what are we going to do? Let's go ahead and clear the screen. And what we want to do is we want to look at the syslog, and we want to look at the last, let's say, 25 entries from the system log. Okay, you can see a whole bunch of stuff in there. So if you see some problems, you can go to the syslog and just do a tail. Next task is to look at the entries in the dpackage log. So go ahead and cat dpackage.log to see what's there. Okay, great. Now let's compare that to the last 5 or however many entries in the apt install log. So we'll cd into var log apt. Make sure we're in the right directory. Okay, good. Then let's go ahead and ls to see what files are there before we do our tail. Okay, great. Now let's go ahead and tail the history.log, and we'll go back 5. TACN 5. Lastly, let's look at the wtemp logs. The wtemp logs record information about login and logouts, and honestly, the information it shows isn't that exciting if it shows anything, but it allows us to use the file and last commands. So let's cd ... go back one directory in var log, and then type file wtemp to see what type of file it is. It's a dbase database file. Okay, so we have to use the last command. We'll type last wtemp, and we get to see what, if anything, has been written, and nothing's really been written, but at least that's how you go ahead and look at it. Now, if you were to cat it, you would see the binary, which is garbage, so that's why we use the last command. Let's move on to the dmessage command. Now, the dmessage command allows you to see messages related to the Linux startup processes. Now, which happens before the syslog daemon is even started, so it can't go to the syslog log files. Now, dmessage is particularly useful for diagnosing hardware and driver problems at startup. Now, 2 useful ways to look at the dmessage logs are with the commands less and grep. Less is useful for viewing large files since it doesn't load the complete file all at once. It loads and displays the file part by part, and this makes access faster, especially for large files. Now, grep is a tool that is used to search for a string of characters, and it is very handy when searching large log files and through big directories of files. grep is actually an acronym for Global Regular Expression Print, which is something you'll probably never need to know what it stands for, but you will find over time you will use grep a lot, and this is just a simple introduction to grep. We're going to talk about grep a little bit more later. Well, let's look at how to view the dmessage log using less and grep. First, we'll go ahead and type dmessage piped into less. And when you see the output, when you're ready to quit it, you can hit Q or hit the down arrow to see more. So go ahead and hit Q to exit out of it. And you'll note that the use of the pipe in this command, dmessage piped into less. Pipes send the output of one command to another, and in this case, you send the output of the dmessage command to the less command for display on the screen. Now let's use the pipe to send the output of dmessage to the grep command for search for information related to the first physical hard drive, which, as you remember, is identified at SDA in the dev folder. So dmessage piped into grep SDA, hit enter, and now you'll see in the dmessage logs any reference to SDA. So that was a quick, simple introduction of using less and grep with the dmessage command. Sticking with logging, let's talk about systemd and journald. Systemd is a suite of basic building blocks for a Linux system. It provides a system and a service manager that runs as process ID 1, PID 1, and starts the rest of the system. Now, its many functions include a logging daemon, utilities to control basic system configuration like the host name and the date. You can maintain a list of logged in users, which we've already used before, and running containers and virtual machines. There's also system accounts, runtime, directories, and settings, and daemons to manage simple network configuration, network time synchronization, log forwarding, and name resolution. So yes, systemd does a lot. Now, journald is a system service that collects and stores logging data for systemd. It creates and maintains structured, indexed journals based on logging information that is received from a variety of sources such as kernel logs, syslogs, standard errors, and kernel audit logs. journalctl is the utility that is used to read journald logs, and you can use specific options with journalctl, such as tacb to look at boot info, tacu to look for info related to specific services, and tacf for most recent messages in the log. Let's go ahead and look at journald logs using journalctl. So let's look at the last 30 entries from this systemd logs. And of course, feel free to look at the help or man pages for journalctl. We're just going to go ahead and type journalctl tacn 30, which is simple enough, gives you the last 30 entries. Well, let's look at what the systemd logs are related to: SSH networking, rsyslog, and cron. Now, you know the specific service names. If you know the specific service name, you can use the tacu. So first up, we're just going to go ahead and do networking. So we'll go journalctl tacu. Well, we'll do SSH first. We can see what SSH services we have running, ssh.service. Now let's clear that and we'll do networking. So we'll go journalctl tacu networking.service, and you may not see anything in this particular view. Go ahead and quit, and instead let's search journalctu tacu network manager, and you can get to see some information related to the network manager service in the system. Quit out of that. Let's go ahead and clear the screen. Type journalctl tacu and rsyslog to see our functional default logging logs. Okay, great. You saw that I did a couple of reboots in there. Go ahead and quit, clear, and last one, let's do cron. Journalctl tacu cron.service, and cron manages the cron tables that runs processes at a certain time. That's basically it. Hit Q to quit out of there and clear. Okay, we're getting close to the end of this section, and let's shift gears away from logging, which is something you will use at different times in your system troubleshooting, and let's get to some of your daily bread and butter of dealing with Linux clients and servers, and that means understanding and configuring network settings. Now, in the old days, meaning really not that many years ago, Linux used the NetTools package, which had a whole bunch of commands that enabled you to read and manage network settings using familiar commands such as ifconfig, netstat, arp, route, and other commands that are still useful today and work on many Linux systems as well as other systems like Mac OS and Windows. You can use these commands on Linux, but you may need to install the NetTools package first. How do you know? Go ahead and type in an ifconfig, and if ifconfig doesn't want to play, it'll tell you to install NetTools. Now, the IP command has replaced some of the NetTools commands, so it's really a package of commands. And it is definitely worth your time to look at the man page and help for IP. Now, shown here on the right is a list of objects to use with IP that provide you expanded functionality covered by different NetTools command. So you've got address, you've got route, you've got NAY, tunnel, and these are some of the things that we'll talk about here in a second. So here's a list of some useful networking commands that you really should know for the short term. Now, there are several important IP commands of note, and this chart is great in that it shows you how to run these commands on using both IP and NetTools. Now, first on the list is IP-NAY, which provides information about bindings between protocol addresses like IP addresses and link layer addresses, MAC addresses, for hosts sharing the same link. So neighbor entries are organized into tables. The IP version 4 neighbor table is also known by another name, the ARP table. So IP adder or IP address, you could type either, is the command that displays addresses and their properties. Now, you can also add new addresses and delete old addresses from your network interface. You just got to be careful when you're deleting addresses, even adding them. Now, the example highlighted here shows the command IP adder add 192.168.1.1/24 dev eth0. So this command adds the IP address of 192.168.1.1 with a net mask of 255.255.255.0. That's the /24. The device is the default device, and it's on the eth0 network interface. Now, IP route is used to manipulate entries in the kernel routing table. So by typing IP route, you'll see a couple of important things, like the default route out of the network your computer must use and the IP range that will be used if DHCP does not assign an IP address. The SS command is a tool used to dump socket statistics. So SS stands for socket statistics, and displays information in a similar fashion, although simpler and faster, to our possibly familiar command known as netstat. The SS command can also display even more TCP and state information than most other tools. This replacement for netstat is easier to use when you compare the man pages and get an immediate idea of how much easier SS is. With SS, you get very detailed information about your Linux machine, how it's communicating with other machines, networks, and services. And you get details about network connections, networking protocol statistics, and Linux socket connections. So it's very, very useful, SS. You just have to use the right options. Now, with this information in hand, you can much more easily troubleshoot various networking issues. So let's try out a few of these commands and see what their output looks like. Okay, so first let's see all the active IP addresses on our Linux host by typing ipadder show. And you'll notice that we have the local loopback, which basically just points to our own network interface card, 127.0.0.1. And then we have ENS 33, which provides our actual local IP address of 10.0.2.6 on a /24 network. Okay, so that's great. Now what we want to do is look at open TCP connections on a Linux host along with their associated process IDs. So you can look at the man page for assistance with SS, and also note that it helps to have some kind of connection like a web browser open so that you can see some connections going out. Now, I have a simple web browser tab open loaded on ESPN. How many TCP WebSockets would you expect to see if visiting only one web page? Well, we're about to find out. Also, I do have another type of a connection. So I go ahead and type SSTACK-TP, and you'll see I have more than one HTTPS connection, and then I got a couple with numbers involved in here. Okay, well, let's just look at our open sockets. We'll type SSTACK4 to look at the open TCP sockets on network, and we'll use these two outputs to help figure out what's going on. So notice I have HTTPS, a bunch of that's all the web browsing, and then I have 129.254, and I look for that on my logs, and I go, oh, that's an SSH connection. So I have an SSH open connection. But what's this thing on the bottom that is a non-HTTPS connection. I'm going to use the host command on that IP address to do a reverse lookup, because honestly, I don't know what this connection is. Let's go find out. So we type host, we type the IP address, we see the output, it's a reverse lookup, and we go, oh, it's pointing to something on AmazonAWS.com. So very likely, we have a non-standard HTTPS connection. Just because we went to the ESPN.com website, now our computer is talking to ESPN.com AWS. Kind of crazy, huh? There you go. Now let's go ahead and look at our ARP tables using the ipnay command. And it's probably going to be boring on this computer. This is a client host, and I don't have any other connections running right now on this VM. But if you look at this on the SSH gateway, the .21 gateway that you log in before you get to the lab gateway, you'll see probably a whole bunch of ARP caches from all the local ARP packets that are being routed. Now, if I type IP route, what I will see is my default route for my local VM 10.2.1, which is great because our IP address is 10.2.6. And then we'll also see 169.254, and that's the IP address that will be assigned and how it will communicate locally if DHCP does not assign an address to this computer. And that's basically it I wanted to show you for now. Let's move on. Guess what? We're on the last topic for this Linux navigation set of information, and we would be remiss if we did not discuss DNS before we close out this presentation, and we don't want to be remiss now, do we? Now don't worry, we're just going to touch upon a couple of important DNS related commands and a couple of important files. The first important file to discuss is the etcresolve.conf file, which is important because it holds the DNS server resolver address. And check it out. If you don't believe me, just go ahead and cap that file. Next, we've already touched on this file, but the etc host file holds local name resolution information. Now, if for some reason you do not have access to a DNS server, you can use the etc host file for the purpose of name resolution. This is a simple text file that contains IP address information to host name mappings. And each line consists of an IP address followed by one or more host names. Now, when you want to look up a host name and IP information, you do have some options. The two best ones are host and dig. The host command is a DNS lookup utility, and we just used that a second ago. And it helps you to find the IP address of a domain name. It can also perform reverse lookups, like finding the domain name associated with an IP address. This is what we just did when we looked at the socket connections to our Linux machine. So the dig command in Linux is used to gather DNS information. It stands for Domain Information Groper, and knowing that is something you'll never need to tell anyone else about what it stands for, but that's what dig stands for. And it collects data about domain name servers. The dig command is helpful for diagnosing DNS problems, but it is also used to you can also use it to display some useful DNS information. So dig provides all the information of the host command and more. In particular, it provides information on several important fields in a DNS record. Two fields that you should know about are the A record, and that maps a URL to a specific IP address, like Harvey to some IP address. Then there's the CNAME record, and the canonical name record, CNAME, is used in lieu of an A record when a domain or subdomain is an alias of another domain. And you'll see what that looks like in a second. All CNAME records must point to a domain, never to an IP address. So when you look at harvey.utulsa.edu, like we will be doing in a second, this will make more sense. Okay, so let's go ahead and look at harvey.utulsa.edu both ways using host and dig. So first, let's go ahead and type host harvey.utulsa.edu. And what you'll see here is it gives us information. It's a little jumbled, but it says Harvey Utulsa EDU is an alias for something else on blackboard.com. That thing is aliased to some crazy looking server name on Amazon AWS, and that particular URL points to two different IP addresses, which is great because that means if one goes down, you'll still be able to get to Harvey and do your homework. Awesome. Well, let's check out dig to see what dig gives us for Harvey Utulsa EDU. It's very similar but differently formatted. So we'll go ahead and type dig harvey.utulsa.edu, and what we see here is we see the CNAME records that says harvey.utulsa.edu, the CNAME record, so it's an alias for this thing called utulsa prod blackboard.com. And then we look and we notice, hey, utulsaprodblackboard.com is alias and with a CNAME record for that AWS address. And then it gives the A records, and the A records ties in those AWS server names to specific IP addresses so that if one goes down, you can still get to it and do your homework. So pretty useful information, a lot of overlap, but Dig kind of breaks it out a little bit clearer.